Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean. DigitalOcean is the simplest cloud platform for developers and teams with products like Droplets, Spaces, Kubernetes, load balancers, block storage, and pre-built one-click apps. You can deploy, manage, and scale cloud applications faster and more efficiently on DigitalOcean. Whether you're running one virtual machine or 10,000, DigitalOcean makes managing your infrastructure way too easy. Head to do.co/changelog. Again, do.co/changelog.
Let's do it. It's go time.
Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel and Go for Slack. Follow us on Twitter. We're at Go Time FM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Hello, everybody. Welcome to Go Time. Today, I'm joined with guest Andy Walker. Go ahead and say hi, Andy.
Hi.
I have Carmen and Johnny both with us again. Carmen, you want to say hi first?
Hi.
Hello.
All right. So, and I am John Calhoun. Today, we're going to be talking about bugs, which is kind of ironic given that we've all had software bugs trying to get today's episode started. And on top of that, our one guest is missing because she has the bug. So we are switching up the topic for today.
Oh, nice. I'm a scab.
What we want to talk about a little bit is just bugs, debugging, how we prevent bugs, how we track them down, different things like that. So we're just going to go ahead and jump right into that. So where do you guys want to start?
So I used to be a long time, Perl developer for like a long time, probably like 8 or 10 years, I'd say. And that's kind of how I really cut my teeth in enterprise development, did a lot of, back-end stuff and mostly just CGI mode Perl. So there were a lot of unholy contracts that we had to make that work. I remember one of the things that I really liked about it was that it had a pretty good, quote unquote debugger that you could easily just kind of hook into. And I got kind of, in a lot of ways, addicted to that. I've noticed that there really seem to be two types of developers, those who are like just all debugger, all breakpoints all the time, and then those who are more just like drop like a print line in there. And Go is definitely, it lets you do that, what with your variants of, print verb and everything. But, recently I have made the switch from, Vim to starting to use VS Code primarily, and the VS Code Go plugin, which of course has Delve integration. And I'd say just like a couple weeks ago, I fired it up for the first time and I had a pretty good time. So I think maybe I'll be switching back.
You be switching back to Vim?
No. Switching back to like using a proper debugger a bit more with, breakpoints and conditionals and such. But by and large, usually I don't get too much more sophisticated than like a print line or like a spew,
Oh, you mentioned spew. Yeah.
That's
so you kind of jumped right in there with like Go specific types of debugging tools.
Oh, okay. Yeah, did you want to get more broad?
Well, yeah. I think just talking about debugging, so whether a person coming to this podcast is a Go developer or is coming from a different language, like is there a universal debugging that spans beyond tools or beyond language ecosystems?
Well, I mean, yeah, I do think, though, that you're right. There's certainly a lot of good advice that you can give on general debugging. But I think also it's important to consider, like, the language that you're working in when you're talking about it, right? Like the various different, kind of special tools that it offers you. I mean, like, in the end of the day, like, if you just stick with, like, the judicious use of print line statements, you can get really far. Like surprisingly far, and almost any language can do that. So,
yeah, I mean, I think the print line statements are interesting because in many ways I feel like it depends on how well you know the code base you're working with and if you have a sense of where to start looking. Because if you're just doing the drop in the print lines and you know nothing about the code, you're going to be at it for quite a while just trying. I mean, it's probably true with the debugger too, but I feel like when you don't know the code, you don't really even know where to put print statements. So at that point, you're just kind of not sure what's going on. And then I'd say there are certain parts of, it kind of depends on the code you're working on, I guess, to figure it out. Like if you're making closures and things like that, sometimes they can be a little bit more confusing depending on, like a good example I can give is middleware. And like if you're writing like HTTP stuff in Go and you're writing middleware where like it does something before and after a handler, there can be some weird times where I've found that it's not obvious because like you think that code got called once and eventually comes back to that code. And like it can make it seem a little bit weird. So you have to like think about how the code works for the, that type of debugging to work.
Yeah, I think having a visual mindset really helps. So like I've had some really, really insidious bugs over the years that after I solved them in less than a day, I was like, oh my God, I'm so lucky, right? Like I'm so lucky that I was able to find that. And I think one of the reasons that is because, like you say, it's important to know the code first. And at least for me, I have like a very kind of almost visual, kind of map of what I've written in my head. And I can kind of see the flow, and it helps me to picture it sometimes. I've had some really insidious bugs, and I think you make a good point. It's important to really dive in and read stuff first. And I think this reminds me of a discussion that I had recently with another developer in terms of like what like makes a good first issue, right? For like if you're doing like open source stuff, and one of the things I think that's really important for that is locality, right? Like, if you want to give somebody a crack at something, you can say, well, I'm pretty sure that it starts here or that it happens in like this subsystem, and like give somebody at least a place to start, because it can be especially tricky if you're trying to debug something you don't know.
Yeah.
Do you find that Go bugs are easier to find in other programs or vice versa? I have my own opinion, but I'm interested in hearing what you all think first.
Yeah, what is your experience, Andy, with Go bugs versus your Perl Enterprise Day bugs?
Oh no, it's so much easier. Okay, yes, there are times when it can be. I think any time that runtime, magic. Any time that like runtime stuff enters into the equation, or rather any kind of like runtime, I don't know what the right word would be, like polymorphism, right? Like anytime you're dealing with, like say interfaces or duck typing, like you would see in Perl and Ruby, anytime you're dealing with that kind of thing, things can become really crazy, really fast. And at least in Go, a lot of the time, you're not dealing with that as much. I mean, if you're doing a lot of empty interface stuff, maybe. But of course, it's best to keep that to a minimum and to lock it down. Also, if you're dealing with like CGO or unsafe stuff like that, which is why of course it's best practice to kind of like segregate those into their own little boxes. But yeah, I find that generally I find it easier. Like again, like I moved away from primarily using a debugger like all the time to really not using one at all. Like I only just started using Delve a little bit, and it's been around for a long time. And I think part of what drove me to not use a debugger is because there really wasn't one available, right? For the longest time, you couldn't really debug Go easily, and even now it can be kind of tricky. So, but Delve has come a long way. So,
I think one of the things that I've noticed is that Go almost had to make it easier to debug because it's making concurrency so easy that like that adds a whole new level of like want to bang your head off the wall, like confusion and just frustration. Because like I agree with like a language like Ruby on Rails is what I used before. So I used Ruby and used Ruby on Rails, and there was so much magic there that debugging some things was just awful. But at the same time, you had this whole model of like, there's one web request, depending on how you have things set up, but a lot of the times you can consider it as like there's one web request coming in. Like I don't have to worry about anything running it, in parallel or anything like that. It's just, that's all I have to worry about. So you can get away with a lot more debugging tools and things like that. Like, this is this specific user doing these things and he's somehow generating all these queries. Whereas like in Go, if I have something running and there's a bunch of things happening in different Go routines, there's no real guarantee that like what I'm seeing in one area is necessarily that one specific, thing that I'm trying to track. So that can sometimes make it, more, like, I wouldn't say Go is harder, but I definitely say that like, because I tend to see more concurrency in Go, that potentially makes it harder, but everything else about Go makes it easier. So it like, it comes out easier in the end.
I mean, yeah, I think concurrency, like normal bugs that you encounter in a concurrent environment, Go's pretty good, right? For like a while now, it has given you the Go routine, right, that is most likely to have caused the problem. And that's pretty great. So like when hearing you talk about Rails, like Rails always used to terrify me because, there's all of this like, what is that crazy like database abstraction model they use?
Active record.
Active record?
Yes.
Active record.
Yes. Right. And so there's like all of this like crazy like runtime meta programming stuff going on with database access, and that always used to just like, as somebody in security, always used to just terrify the hell out of me.
Oh, that's just Ruby, my friend.
Oh,
no shade. No, I mean, don't get me wrong, no shade against Ruby, but back in the old days, method missing was my friend. You know what I mean?
No.
Like you can do magical things with that thing.
Yeah, that's true.
Method missing was my biggest method.
So now would that basically just hook into, like at runtime, it would tell you what somebody was trying to call on you that wasn't there?
The basic way it worked was whenever somebody called a method that wasn't present, it would call that, and then you could define the method as you were going. So like a lot of meta programming was simply wait for this to get called and then dynamically throw that method in there, and suddenly it's magically there. And it was confusing, but it was also pretty cool at times.
I mean, you want to talk about hard to find like bugs. That was, half the time that was, the source of my issues. Basically looking in places and not realizing, oh, there's something that's actually going to be injected in the code that actually gets run, at some point that I can't quite read. It's not obvious, right? So I think the biggest problem I have, and this goes back to the question I was asking before, the biggest problem I have these days is they're more design kind of related issues that sort of surface. I don't know if I can call it a design bug, but they're more like, I don't have sort of runtime kind of issues coming up as much anymore. Like because of Go's compiled nature, I don't, I eliminated an entire class of bugs out of my life, right? But basically now I have a lot of logic bugs. The code compiles and it runs and does the right thing 99% of the time. But in a particular code path, or we're given a particular set of inputs, I get, unexpected behavior, right? Those are the things that these days I'm finding to be harder and harder to find. Like, and then you add to that, like, you were saying, John, add to that like a layer of concurrency, then that can indeed make things a lot harder to sort of find. But I think Go by design and perhaps by the way it's used, I feel like it's okay. We go out of our way to make things explicit as Go developers. And that, I think that has removed like the cognitive burden of trying to track down like, stuff, some smart, clever things that developers might be used to in other languages.
Yeah. I mean, like when you guys were talking about method missing, it reminded me of this technique we used to use at my last job for a long time, which basically, so, one of the problems that we had was all of this stuff was in CGI mode Perl. You'd get all of this for like every single web request, you would get all of this kind of these branching dependencies pulled in and kind of compiled on the fly per every web request. So we wrote we wrote a library that like basically just abused the Perl universal autoloader to let us basically just do away with imports entirely and just call things by their like fully qualified name. And then if the code path called it, then it would compile that. So like, that kind of thing is what I always think about anytime somebody says to me, Go, it's so boring and it's not very expressive. And I'm like, that's great. That's fine. Like, try going in the opposite direction. Like I'll sacrifice a little bit of that kind of magic if it makes my bugs easier to find, even if it makes things longer.
Yeah. And I think that's by design. Like I think that Go's readability and one way of doing things. You can quickly get a sense of what the code's trying to do, and then also lets you help debug it. Now, debugging, you've talked about a lot of cool things here. One is, depending on the programming language and or possibly the programming paradigm, whether it's an interpreted language or it has a virtual machine or whatnot, you're having different flavors of debugging. So there's no one programming language over another, it's just different flavors. But debugging is just inherently difficult, right? I remember that Kernighan quote. I've used it, probably overused it. You've probably already heard me say it on the show, but that, let's see if I can get it right. Like, if you, debugging is twice as hard as writing a program in the first place. So if you're as clever as you can be when you write it, then how are you ever going to debug it, right? That was Kernighan saying that. So that's just a part of programming, no matter what language you get. But one of the things I wanted to ask you when you were talking, Andy, was you said, oh, thank goodness I have a good visual memory, because then I was able to get this really insidious bug. And I wanted to follow through on that, the idea of what do you mean by that and a visual memory?
I don't want this to sound like I'm kind of trumpeting some special ability that I have, because I don't believe it is. It's hard for me to explain, really. Like, when I'm debugging, it's an intensely visual process for me. I like to imagine that it's like this for a lot of people, that there's this kind of sticks and boxes model in your head that represents like the layout of the memory and all that stuff, and the kind of control flow. And for me, what I see when I'm really, especially when I'm really trying to track something down, is it's almost like, I don't know, it's like a map or something. It's like a series of interconnected rooms and how they connect with each other. And that, for some reason, there's always that visual component for me. And that's just, I don't know, that helps me.
So I have a story about my most impactful debugging moment as a software engineer. And I've told it on Twitter, but I'll say it here. And it's a story that Rob Pike said, which is the most useful programming advice that he ever got was when he was working at Bell Labs with Ken Thompson. And I'm going to say this, it's appropriate, right? They're the two creators of Go, Ken Thompson and Rob Pike. But the two of them were pair programming on, I think, a compiler. And Rob was at the keyboard driving, and Ken was standing behind him. And they were working fast, and things broke, often visibly. And Rob would just he just reflexively would dig into the problem. And so he'd examine stack traces, or he'd put printf statements everywhere. He'd invoke the debugger. So all these things that we talked about in terms of what ways you want to debug. But Ken would just stand and think. And he would ignore Rob, and he'd ignore the code that Rob just had written. And then after a while, Rob would notice a pattern. And it would be like, Ken would often understand the problem before Rob would. And he would just suddenly announce, oh, I know what's wrong. And he usually was correct. And Rob realized that Ken was building this, and this is something that you said, Andy, this mental model of the code. So when something broke, it was an error in Ken's mental model. And so by thinking about how the problem could happen, he'd intuit where that model was wrong, or where the code must be not satisfying that mental model.
Mm-hmm. I think it's an intensely personal thing, too. I mean, like I say, I'd like to believe that everybody, has the same kind of visual model that I have, but I don't think they do. I think everybody's maybe slightly different, but it is something that's, I think, important to cultivate. And one of the things that, at least to me, that has really helped me is, one, working in Go, which is a language that is comparatively, boring, but I say that as a compliment, right? Like I love that about it, but also working in a language like that, and then also kind of turning off most of my syntax highlighting has really helped out a lot too. And I don't want to be that guy who's, the turn off his syntax highlighting hipster, but, because I do still have some, like I highlight my strings and my, whatever. But I think one of the things that's really helped me do that is turning that kind of down somewhat.
One of the things that's interesting is, like Carmen, you were talking about how Ken would not actually be coding or looking at debuggers or anything like that. And I didn't think about it until you said it, but I think that's part of what shaped how I debug now. When I was in school, I was on they had a programming team that did ACM, ICPC competitions. They're things like Code Jam or Top Coder, basically algorithmic competitions like that. And the way it worked is you had one computer and 3 people on the team. So whenever you had a bug, it was really wasteful to sit there and try to debug it on the computer, because there's 2 other people who could be solving different problems and you're blocking them. So there was always this rule of if you have a bug, you just immediately print your code and step off the computer and the next person steps on. And like if you want to get like 2 or 3 outputs or something to like give you something to work with, you can do that. But the idea was you shouldn't be pulling up the debugger. Like if something's wrong, it's probably a logical issue or something like that. Like you need to go through and make sure you mentally understand what's going on in your code. And that's where a lot of my debugging sort of skills came from, I think. So as a result, I don't pull out a debugger very often, but I think it's just an artifact of that. It's not necessarily that I dislike debuggers. It's just that's the way I've done it. And I think whenever I see people with the debuggers, they're probably doing the same thing. Like I'd always sort of start with like, here's roughly the code path my code's taking. And I'd pick somewhere in the middle and be like, is my code like, or, can I try to trace to this point? And like, is this thing going wrong by this point or is it after this point? And with the debugger, I think it's the same. You're trying to look at something at some point in time and saying, is it what I expected right now or is it something wrong?
Yeah, and conditional breakpoints can be really powerful for that kind of thing too. But again, you kind of have to know what you are and are expecting and what might be wrong and where it might be, and so a lot of the time recently when I've opened up like a debugger, it's cool, but it hasn't there's been I think one time since I switched to VS Code where I was like, oh, thank God for Delphi, that's so cool. But still, most of the time, it's just me popping open a terminal and using plain old print line so that it's easier to find and remove later.
Yeah, debugging is really just problem solving at its heart, right? And problem solving, I've given talks about mental models because I really think the two are intricately connected. And when you said, oh, I'm glad I'm a visual learner, I say, aha. Because I feel like what we're trying to teach is our mental maps. You said a map, and that's also, a way of thinking about things, or visual spatial things. That's why we whiteboard so much, so that we can see the hierarchy in things, or we can see the relationship between things.
Yeah, I mean, I guess it's that BA in CS coming out, but
wait, repeat that. What is a BA in CS? I already know the answer, but I want you to say
it's funny. So yeah, I have a Bachelor of Arts in Computer Science, and it's one of the things I enjoy telling people. They're like, oh, I'm such an imposter. No, it's okay. I have a Bachelor of Arts in Computer Science. It's okay. But yeah, one thing is I guess a corollary to the quote that you said before. I sometimes say something to the extent of debugging would be my very favorite thing about programming. If it wasn't for all the damn bugs I'm trying to track down, right? It can be so challenging and so deeply satisfying. It's nice to write an API and it works the first time, right? But if you're finding out what was causing that type assertion error ended up being a shadowed error variable 4 or 5 calls deep, which is a real thing that happened to me, and then you finally fix it and everything works, you're like, oh, yes, I'm so smart, right?
Is that one of those things where nothing ever worth anything ever came easy? So we're all gluttons for punishment and we need debugging in our lives?
I don't know. I mean, it's just for me, it's always some of the greatest satisfaction that I've ever had as a programmer has been fixing some insidious, little bug.
This episode is brought to you by StrongDM. Manage and secure remote access to any database, any server, on-prem or in the cloud, and environments. They make it easy for DevOps teams to enforce the security and controls InfoSec teams require. So if your engineers need access, you need StrongDM. So what can StrongDM do for your team? First off, more control, less hassle. Grant or revoke access to any database or server in one command. Use your SSO to manage access to every database, every server and environment. Second, total visibility. StrongDM upgrades your audit logs, log every permission change, every query, every SSH, and every RDP command, and know who issued those changes. And of course, faster SOC 2 compliance, easily enforce access controls, and instantly answer auditors' questions. Head to strongdm.com/GoTime to learn more and request a free demo. Again, strongdm.com/GoTime.
feel like for me, it's either the greatest satisfaction or the biggest frustration.
Aw.
Oh yeah.
Like there's no in between. It's either I spent all this time and I'm like, are you kidding me? That's what's wrong. Or it's the opposite of like, oh yeah, that was like a really tricky thing and I'm proud of myself for figuring it out. But it's never the middle. It's almost always like, how in the world did I let this slip in there? Or how is this what was, causing my code to break?
Yeah, it's like that.
How much do you estimate? I'm just going to ask a poll here. Everyone, Johnny, Andy, John. What percentage of time do you think you spend validating and debugging your code? Andy?
Oh man. Debugging?
Yeah.
I don't know, 30%.
John?
On a good day, like 25%. On a bad day, 75%.
Wow. So we'll average it at 50.
It's probably not actually. I probably have bad days less often. It probably comes out to around 25, 30%.
Johnny?
I'd say that's in line with what I've seen. Like usually around 20% of my time, which is in stark contrast with how much time I spend writing tests. I think these days I spend probably 60% of my time writing tests.
Ooh.
And then, the remainder is just basically trying to come up with a feature. I don't always do TDD. Sometimes I write my tests after. As long as I have tests, right? I don't care. Come at me.
Well, I mean, it's like, hey, as long as you unit test everything, it's not going to break, right?
Yeah.
I probably should have asked that at the start, though. Do we count testing as part of finding a bug? Like,
Yeah.
because that's hard. Because like when you write the test,
It's a postscript.
I think it's part of this debugging mindset, right?
Yeah, I think so. Yeah.
I think it absolutely matters. When you test, you were already, it's like your future self already knowing the cases to debug.
Well, so like it's like somebody said in the comments, Anthony Starks, he says that it's like debugging is like being the detective in a crime movie where you're also the murderer.
I love that one.
I was reminded of that because like it's like the testing that you add afterwards is like the part where like there's the freeze frame and like Joe Friday comes on and be like such and such was arraigned in the Supreme Court of like it's like the postscript to the murder mystery. It's where like kind of everything is laid out. You're like, okay, like let's write some tests that specifically exercise this this bug case that I had, and that's a pretty good practice. I don't think a lot of people really talk about. It's like you find a bug, you should exercise that, right? Because clearly your unit testing didn't catch it, right? So
in my Go code, I can mention how having table-driven tests has helped me tremendously in coming up and easily adding cases in my test suite that I otherwise wouldn't even think to test, right? So, for those who don't know, is basically you set up a structure, you either using map of anonymous structs or whatever, however you want to track that. And basically you just iterate through every single test case that you initialize that map with, or that set of, could be a slice, however you want to track that. And basically in your test code, you just then going through those test cases and then, using subtests to, actually run a test. So whether I have a single test or 3 when I start out with, I always start out with table-driven tests. And even if I just have one case in there, because I know I'm going to come back, I'm going to add some more. And even if I can't think of one right now, I'm going to start with the one I have, and then I'm going to be basically sitting there and thinking, okay, what are the different ways this could fail? Because when I do that, right, I'm anticipating bugs that could arise from unexpected behavior, right? So by setting myself up in this mindset, right, I truly believe spending time writing tests has a proportional impact, right, on the number of bugs that you have in your code.
Yeah, and I can hear like Damian Grisky silently screaming from Canada. So I should probably mention at this point that fuzzing is something too that we should all consider too. And I'm including myself in that, right? Because fuzzing is kind of like writing all of those tests, but not having to actually do it. And so it's definitely something that I've been meaning to do more of. And so I would encourage all of our listeners, myself included, to look into fuzzing and fuzzing your software.
Yeah, like even to add what Johnny was saying, I don't feel like there's many things more satisfying than like when you have a bug and you just add one line to a test case, like to a table, and you can replicate that bug. Like those are the nicest bugs to basically be presented with, because it doesn't take a lot of like effort to reproduce them. It doesn't take a lot of it usually doesn't even take as much time to debug either, because you can just throw that in there and it's like, okay, now I can go find it, I can replicate it, and I know it's not coming back in the future. But whenever there's not a test case that even comes close to it, you're just like, where do I start? What do I do? Like that, because reproducing bugs is a huge, huge issue.
Yeah, you say, where do I start and what do I do? And I think of it in the sense of, how do you teach debugging skills? And I came to the conclusion that typically, the most effective debugging draws from extensive experience. And so how do you give the novice that experience? And I think these kinds of tests, like table-driven tests, do exactly that. It starts to get them to build up that experience and mental model and the scope and the locality of things bit by bit by bit, so that they can understand it.
Well, yeah. And I think that's where good beginner issues are certainly helpful too. For somebody who's learning a new language, one of the things I might recommend in terms of like learning how to debug is, well, first of all, pair programming. I think that's probably like step one. Really, if you want to learn debugging skills, is to really just get somebody and sit down either in person or virtually, ideally in person, right? Because it's also kind of a diversity thing, right? Everybody's minds work differently, and having more than one person there can also help. But especially if it's like somebody with more experience than you, and somebody who's patient and is willing to kind of walk through an issue with you. Maybe even they know the solution already themselves. They've just kind of earmarked it for educational purposes.
Yeah, the way I see that, like as a visual person as well, is that my mental map just needed filling in, or my mental map is quite different, and I'm helping, because of all of our mental maps, they're just approximations, and we're trying to help bring people along.
Mm-hmm. Another thing that occurred to me is really important was in terms of debugging, always getting like that, especially if it's not something that you found. Like if you're working on an open source problem or something, that kind of minimum pathological case, that it will reproduce it in the shortest number of lines possible. I think that's like tremendously important. Like really distills that poison pill down to its very most basic essence, and I think that's really, really, really helpful. Trying to find exactly what causes something and have that ready ahead of time for whoever might fix it.
So on that note, like Carmen, before the episode, you had mentioned a bug where I think it's in a specific version of Linux. Like when it comes to a bug like that, where it's really, really hard just to say this is the one test case that breaks it. And I think we've all probably seen something like this, probably not at that same scale. But we've seen a bug like that where there's not an easy way to reproduce it, whether it depends on the time or it depends on multiple things happening, in concurrency, whatever it is. So how do you guys tend to start when you're trying to debug that type of complex issue?
At first, it's like the stages of grief, right? Denial, and just anger, like what is going on, right? And then
this should never happen,
right? Like, right, corner case. Like I can't if every time I'd said corner case was an actual corner case, this would be like a very bizarre, like Sideways Stories of Wayside School kind of world, but it's not. And so it's like after that, a lot of the time it's just kind of like, okay, where could this possibly be happening? I just throw stuff against the wall. Let's see what sticks, run it 100 times, run it 1,000 times. Like those are the hardest bugs, is like those kind of flow control, edge case kind of bugs. And, that's at the end of the day, that's where, a stack trace is particularly helpful. Sometimes that's all you get. Or, once you've kind of got an idea of like where it's happening, I think this is one of those cases where a debugger can actually be really helpful. I mean, sure, you can still just like drop a bunch of print lines of like all of the adjacent stuff that's around where that site is. But with a debugger, like an interactive debugger, I should say, you can say, okay, well, I know this happens 1 out of every million times, but the reason it happens or appears to happen is because of this. Let me just go ahead and set a conditional breakpoint or something like that. And then when it fires, okay, let's take a look around. Let's see what happens around here. I mean, sometimes you can't do that. And then just drop everything into spew based on that condition, something like that. So
in my case, the kind of bug I know we're talking about here is one, you pasted the link in for us, John. It's a runtime issue with memory corruption on Linux 5.2. Like that's a change in a kernel.
Yeah.
It's almost like, your code worked on this particular version of an OS yesterday, and then maybe there was a fleet roll, and you just got a new, kernel upgrade, and then now all of a sudden your code is breaking, right? You changed nothing, right? All of a sudden you're getting these kind of memory corruption issues. Like, where do you start with that, right?
I mean, continuous delivery, right? and bisecting.
Yeah, but
maybe
bisecting is that, but this is the reality that many of us live in for 2019, or if this airs 2020, right? Which is the upstream bug. Like think about 20 years ago, we would run a thing on a fixed host, right? And we didn't have to worry about, everything was pinned, the OS was pinned, and now everything is moving under our feet. And so we now have to understand several levels of our dependencies, both on the operating system level or just upstream, right? So upstream bugs are the gnarliest.
I mean, like you even mentioned continuous deployment and that continuous integration and all that stuff, which helps to a degree, but I think you also have to remember that what you're creating makes such a big, like the Go team cannot have continuous deployment or anything like that, because if everybody had to reinstall a new version of Go every day, we'd all lose our minds. It just wouldn't work. Like that's not a realistic approach. But like if I'm building a website and something's wrong, I can push a new version out tomorrow.
Yeah.
So I think like the way we approach these bugs and like the way that we have to like consider them so drastically depending on what we're making and how people are consuming it and all of that.
Sure. And yeah, I mean like, but even if you don't have some kind of continuous integration system, I mean, I know they have got like GoBot or whatever, right? Like internally that does a bunch of this stuff. And it's like constantly hammering away at stuff as things are checked in. But, even without something like that, you kind of sometimes just have to do it mentally and take a step back and say, okay, well, it's very Sherlock Holmes, right? You eliminate sometimes it's different though. Like you don't have the time to necessarily eliminate like the impossible, because like, how do you know what's impossible, right? Sometimes if like after you've banged your head against something for a little while, it's like stepping away both physically and metaphorically can really help too. It's like, okay, well, what if it's not me? And I think that's something that I wish I did more, is like being able to kind of take that break earlier and say, okay, well, how likely is it that this is coming from outside? And that's not very common, but it has, there have been a few times where, like it's an upstream bug, like it's a dependency thing. But, thankfully modules are going to save the world, right? So.
Oh, well, I just, when you say you need to rage quit or you need to go and take a walk, like that's been, right? Like, I think that is one of the best things. I know a colleague of mine, Julia Ferrioli, one of the things she would have is a jigsaw puzzle on the table in her dining table. And she would just need to get away from the problem, and she would just go relax the mind and just let it kind of percolate in her mind while she did a jigsaw puzzle. And I don't have that because I don't have the space, but man, I thought that was brilliant. And especially because, again, we're talking about problem solving. We're talking about getting a model of the system. The system is now interdependent in multiple layers and levels, and you have to check all of those and your knowledge of them. So yeah, I think getting away and because sometimes when you're chasing it too hard, you're doubling down on your interpretation of a thing instead of stepping back and saying, are my assumptions even correct in the first place?
So I used to smoke, which I'm not encouraging to anybody, but the only upside I ever saw out of it was that if I ever had a problem, I would walk outside and smoke, and that forced me to step away from my computer and everything else. And the other thing that it did was, because you're sitting there and you sort of wait till you're finished smoking, even if you had an idea, you wouldn't rush back to the computer immediately, you'd wait till you finish smoking. So like, you'd have that like, oh, maybe this is it, but then you'd stop for a second and think about it a little bit longer and be like, nope, that's not it. And like, it forced you to sort of step away from the problem and not type on your keyboard and not do the stuff that is in many ways distracting. So it's one of those things where I've learned it's not the smoking, it's the stepping away from your computer, like your keyboard, just like walk away from the keyboard so you can't even type. You don't want that temptation, and like try to get that like, couple minutes to yourself to think without, distracting yourself with everything else. And that's been a hugely valuable lesson for me to learn.
Well, who knew that talking about like debugging was going to get so philosophical? Like, we're talking about stepping back, expanding your viewpoint. I'm going to add another one, actually. Let go of your ego. And the concrete advice that I will give for that is this. Like, how many times have you been like, oh my God, this is insane. This must be some like Turing problem level bug. Like, I can't solve it. And then you finally, you call somebody else over and they're like, didn't you forget like a parentheses over there? And you're like, oh, and it's just like, like do that as early as possible. Like, I mean, I wish I could say that I'm good at it, and I'm actually terrible at it because, like a lot of programmers, I've got an ego, and, my self-worth and like how smart I am is like tied up in that. And so like a lot of the time it's like, no, man, no, I'm going to solve it myself, whatever. No, but just let that go. Have somebody come over, take a look at it. It's going to be better. It'll be fine.
I think debugging should absolutely be approached from this socio-emotional, philosophical standpoint. One, because no one tells you when you start out being a software engineer or developer that failure is the default, right? It's, and it's kind of that trope. I think it's the XKCD comment, like new programmers say, oh, yay, it worked the first time. And then master programmers say kind of dubiously, it worked the first time. I don't trust that, right? But it just goes to show that debugging, again, is problem solving. And as all of you said, it takes up anywhere from a quarter to half of our cycles, or of our time, just trying to figure it out. And it's normal. And, I would, in my early days, I just thought I wasn't going to be cut out to be a developer because I took it way too personally. Oh, I'm just not smart enough. And then I saw somebody, I paired with someone, as you suggested, Andy. I saw someone who I thought was like the elite developer of that day. It was like 5 or 6 years ago, spending 50% of her time kind of looking at it and then talking outside and doing the rubber duck and saying, now what's with this? And and that's when it clicked for me. Like, oh, this is normal. And I just try to say that to anybody new entering into the industry. This is normal, and this is just part of the process, and you're going to enjoy it when you figure it out. And some days you're going to need to go out and not have a smoke, because we don't condone that, but maybe go take a walk and a break.
I'm being ashamed now.
Yeah. No. The other thing, I won't say it.
I mean, Matt always, like when Matt's on the show, he always talks about how like it's impossible to estimate how long something's going to take to build. And I think part of that comes down to, like you said, if you run into a tricky bug, there goes an entire day sometimes. Like just figuring out what's going on with that bug. And you can't predict that ever. And like that's like part of the reason why every developer is like, we try to guess how long things are going to take. But at the end of the day, you just never really know if it's going to take, a day to figure something out, or if you're just not going to have any bugs at all. It's just going to be a straightforward thing.
Before we transition, basically 2 techniques that I use that have helped me tremendously in bug hunts, or really any throughout my day, is I use the Pomodoro technique. So at any one time I have a 25-minute timer. Basically, that's going to audibly ring and says, hey, snap out of it kind of thing. Sometimes it's good. Sometimes it snaps me out of my concentration. And I'm like, why did I have this thing on? But most of the time it works out. At least it gives me sort of a, how when you're in the zone, right, the whole day could go by and you don't realize it. The next thing you look outside and it's dark out. Well, that's all well and good, but I can't afford to see the whole day go by. I have too many balls I'm juggling, so I need to be cognizant of the passage of time. So where am I going with this? If I have 2 Pomodoros go by, right? I hear the bell ring twice, right? And I'm on the same problem, trying to troubleshoot the same exact issue, right? I've already had 2 audibles. That tells me, okay, you need to do that step away thing now, right? You need to go for a walk or call somebody in, pair with somebody, whatever it is. But that's basically that's the limit I give myself, right? You say, okay, so you spent at least 50 minutes on this thing, so now's a good time to step away. So like I already have that expectation of myself, so that I'm trying to wean out the whole thing you're talking about, Andy, like the ego and the stress you add to yourself. Oh, I should be able to figure this out, right? So I'm basically saying, hey, you're a professional. Your time is valuable, so spend X amount of time on any one thing.
Yeah, that's really helpful advice, because it is like also a thing, like how much time should I spend on this, and how much time is until I walk away. So I need to go get myself a Pomodoro timer, because I have done that. It's like nerd pride is on the line, and I've spent a day doing this when really it would have been better for me to walk away. And I had no visual cue to do that if I didn't have, a schedule going. So that's really good, useful advice.
Yeah, I think time boxing is really powerful. I can't do it. I'm working on it so hard. I've got like 2 hourglasses and like at least 3 Pomodoro apps. And like every time, like I'll be like, all right, today's the day. Yep, today's the day. We're Pomodoroing. We're time boxing this perfectly. And like I get like 2 or 3 through it. And it's just, I don't know, maybe it's just a matter of pushing it. I've started doing bullet journaling. That helps a lot for like my kind of time management. It's like, all right, what's the crap that I need to solve today? Reorder it at the end of the day every day. But yeah, I agree. I think Johnny's right. I think time boxing can really help. And whatever hard and fast rule you need to know when to step away from something, you should take it.
Have you ever, as a debugging device, ever gone to the whiteboard or gone to a sketchbook and doodled? I don't have a whiteboard anymore, when I'm not in the office, but I have a sketchbook full of debugging sketches. I don't know if anyone does that or if that's just me.
So
all the time.
Every year, Walmart has their back to school sale, and they have notebooks for like 20 cents or something. And every year I buy like 50 of them, and my wife looks at me like, why do we need this many notebooks? And I'm like, trust me, I will use them.
We should all, take pictures of some of your sketches and maybe just tweet them out or something and just say debugging sketches or something, because I think that would be lovely, especially as we are trying to communicate our mental maps to other people. And sometimes I really love when someone will sketch a thing just, oh God, speaking of the kernel debug, I think it was like 35777 on GitHub, which is the, upstream thing. The person that was in on that, Mr. David Chase, he's a colleague of mine. He, on the back of a napkin, talked to me about a certain garbage collector method. But I've saved that sketch because there was so much goodness in it, and I just love sketches. So I really want everyone to just hashtag debug sketches.
Debug sketches.
All right, hashtag debug sketches. Do it. Tweet it out if you hear this. I want it. You could @ me. I just want to see everyone's sketches.
Okay. I honestly think that if everybody took the time to diagram things in the way that makes the most sense to them, like not just computer science, but like so many different things, everything finally clicks when you have that visual kind of representative model in your head that works for you. And for some people it's different, right? Like how you understand like the real numbers, for example, or something like that, or irrational numbers. It's different from everybody, but once you have it, it clicks. And I think that would be a very helpful thing to share, because sometimes if somebody else has this mental model that is just so concise and so perfect, and then you see it for the first time and you're like, all right, that's it forever, right? Like that fundamental misunderstanding is gone from my life forever. So I think that's something we should share more. And I don't think a lot of people realize that they do it, right? They're like, okay, I got this picture in my head and it represents this concept, and I kind of always return to that anytime I'm trying to think about it. But everyone's different. So your mental model might be like the thing that is somebody else's breakthrough, and you just kind of casually use it every day.
How do we teach debugging skills? Or how would you? Like if you had to do this with pairing with a junior, what were some of the things you use in your toolbox?
Pairing.
Pairing.
That's the only thing I've been able to find that is effective. I mean, I can send them blog posts, I can give them books to read, I can do all that, but there is something out of sitting down with somebody, you verbalizing your thought process and walking through something alongside with them, right? And for them to hear how you're navigating, in your mind, how you're navigating the code, what you're thinking as you do. That doesn't mean they're gonna think the exact same way. That's the magical thing, right? They're gonna pick up, right? You're cueing things for them, like, oh, okay, I didn't think of that, right? So they're picking up things. There's nothing quite like pairing with somebody to go through that process to actually really demonstrate the art of debugging.
Well, and it's like, I think it was Carmen that said earlier, debugging is primarily an experience-based skill, and the only way to quickly teach an experience-based skill is to have somebody with experience stand there with you and give you the hard lessons that they learn as shortcuts, right? That's the quickest way to convey that kind of skill, I think.
This episode is brought to you by GoCD. With native integrations for Kubernetes and a Helm chart to quickly get started, GoCD is an easy choice for cloud native teams. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale build infrastructure on the fly for you. GoCD installs as a Kubernetes native application, which allows for ease of operations, easily upgrade and maintain GoCD using Helm, scale your build infrastructure elastically with a new Elastic agent that uses Kubernetes conventions to dynamically scale GoCD agents. GoCD also has first-class integration with Docker registries, easily compose, track, and visualize deployments on Kubernetes. Learn more and get started at gocd.org/Kubernetes. Again, gocd.org/Kubernetes.
I think even if we look back at like a school level, I remember seeing like tests or homework or whatever it is where they'd be like, find the bug in this code, but then they'd have you looking for silly things like semicolons missing. And I'm like, if you're going to have me look at printed out code, don't make me look for silly things like that the compiler can just tell me what's wrong. Mm-hmm. I think instead it makes more sense to present them with like, here's some code. Maybe it would be like, and here's like how we're going to test it. Like give us a couple test cases that you think would be useful for this code. But then on top of that, you could have them like trace some code and be like, here's what the code's supposed to be doing, here's what it's outputting. And you could keep these relatively small, but you could keep it sort of like math problems where it's like, here's a simpler program that you've never seen before. Try to figure out what's causing it to print out this output when it's supposed to have this output or something. And I think if we did that more with students when they're learning to program and focused on this, like you need to understand the logic, not like so many people think about programming as like just putting these words on the screen when most of our job is thinking about how things should logically flow and like thinking about, all of that, not the actual putting words on the screen is like the after effect. It's like, it just comes later.
Pairing is difficult to do in a remote fashion, right? Although the tools are getting better and better and better. I often found that one of the remote ways you can help with debugging is, even though it takes more time on the people doing it, to maybe narrate your thought process in an issue.
Sure.
Yeah.
Yeah, I think, that and kind of like open. So like one of the things that occurred to me when we were talking about like pair programming is I think that is one of the things that is more difficult when you're in a primarily remote working environment. Now, I'm not going to go so far as to say that it's impossible, but I do think it's more difficult, right? Because sometimes, how many bugs have been solved by hearing somebody fling an expletive over a cube wall, right? And you're like, what's that guy so mad about? And then you go over there and then all of a sudden, you're that other pair of eyes, right? So like, I do think that there are extra steps we kind of have to take to like facilitate that in a remote environment, like open office hours, stuff like that. I think that's important. Reaching out is important. Getting just because there is that ego hump to like actually reaching out. It's one thing to just like make kind of passive aggressive, like disgusted sounds and hope that somebody will notice, but it's completely another to like actually, type out to somebody and be like, please help me. So I think that's something we need to encourage as much as possible. And, office hours, stuff like that. I think it can be good, but I don't have a full solution.
Earlier you'd mentioned like letting go of ego and like just admitting you don't know that something's wrong. And I think sometimes it's not strictly ego. It's the fact that like they're in a different time zone or something. So it's like, I have 2 hours until they're up. I can't ask for help right now. So like, that's one of the reasons why not to get into the whole remote versus like local, but that's one of the reasons why I think junior developers are sometimes better served in a office, is because a lot of that stuff is more available. And you don't feel like you're bugging somebody as much to say, can you look over at the screen versus let's bring up the screen share and get your mic out and your headset. Like it's a little bit more involved, or it feels like it. And I think that can discourage them from doing things that could really help them grow quicker.
That is a good point.
But you can also like start off early and just be like one of the things that I tell people, this is kind of a pet peeve of mine, but like I really hate it when people ask to ask instead of just asking, or what
does that mean? To ask?
Well, certain people will just be like, hey, what's up? And then like 3 hours later, I'll be like, okay, well, yeah, here I am. And then they'll ask me the question. It's like, come on, like this is the reason we have these out of band communication channels. Like, I appreciate you trying to be polite. And I think, that's when there's always a very, very polite thing to say. very polite conversation where I'm like, hey, I know, just so you know, I'm not always here, but I'm always willing to help. So you just throw whatever you want in this channel, and I'll come back to it, and we'll talk about it then. Like, I think that is something you need to start with early, especially if somebody's transitioning out of the environment. Just be like, if you've got a problem, put it in here. I may not be there, but when I get back, we'll talk about this. And so that can kind of help to overcome that, especially if you hit it early.
Especially if they know that like it's okay to say, can you help me with this? And then even if they come 15 minutes later and say, oh, I figured it out, like that's okay. I think some people worry about doing that, but it's like, I don't mind reading a chat that says, can you help me? Never mind, I figured it out.
No way. I love that. Wake up in the morning and somebody's like, never mind. I'm like, great.
Yeah. I love that we're talking about maybe the more human side of this kind of thing, right? Like we also have to debug human intention and debug human emotion. And I think that is also really hard.
Well,
Yes.
I mean, everybody. So this is something that I was gonna talk about for the episode that I was supposed to be talking about today. But like humans. This line of work, as much as we might want to imagine that it's some sort of perfect, like technical meritocracy where ideas speak everything and like the power of your idea. No, this is fundamentally a human endeavor, just like anything else. It's just that we tend to like try and push that away and forget about that. So that makes debugging hard. That in itself is something I feel like we have to debug.
It's like a meta debugging within the technical debugging.
I mean, I don't want to get too wanky about it, but sure. Like, I feel like I might have gone a little off the rails there.
Debug yourself.
Yeah. Well,
Debug
you know
yourself. Oh, that could be another hashtag, Johnny.
I know, right? I'm here all day.
Thank you.
So I think that's it. Thank you everybody for joining us for this episode of Go Time.
Thank you for having me.
Thanks. Take care until next time.
All right, thank you for tuning into this week's episode of Go Time. If you're not yet, hang with us in Go for Slack. We have a channel called Go Time FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.